People of Earth. I thank the makers of open broadcast software for making it intuitive. I kid, it's actually by far the best broadcast software I've ever found. You get parallax, but my voice is hurting because I just did this tutorial and it was 25 minutes long. I got through it, I was like, yeah, I've not made a one for ages. You know what happened? Notice how there's no audio recording yet you can still hear me. That is because if you have a webcam and you've disabled the webcam's audio, but you have a desktop mic and that is enabled in the settings, okay, and the microphone is on, it doesn't record the desktop mic. No, the webcam audio being disabled overrides this. Please fix that. I don't know if it's intentional, but it's... Not gonna swear. That's a good thing. I've already had a practice run through this, and I said before it was all improvised, I'd done no preparation. Well, now I kind of have, and I don't think it was that good, so we'll see. Maybe I'll do it better this time. Pointers! Pointers for beginners, pointers for average, whatever. Just pointers. Pointers are fun. And evil. Anyway, we don't need to look at this anymore. So, I just do this for sanity. You shouldn't do this for every C program you ever write, obviously. But I have bad habits, and I don't want to think too much. Now, I've not been doing C++ at all. As usual, my job is a web developer primarily, so JavaScript, figure out why that jQuery library doesn't work, why doesn't this button work in Firefox but it does in Chrome, that sort of thing. Not pointers. Now, before we go into this, I ask you, what is a variable? Do you know? We're going to be dealing with integers. So, I'm going to use an example I have in my head. Int. Very technical. An integer is usually 4 bytes in C++. I say usually, like 99% of the time it should be 4 bytes. I think the standard says it has to be this, but you never know. So, integer, what should we call it? Let's call it A. And let's say it equals, I don't know, 2. And then let's have another integer, B equals 3. So A is just a name. It's a human readable name, not a great one. We should really call it Alonzo. You can tell I like Doctor Who, can't you? So Alonzo is 2. Now, that's kind of abstract, actually, so I'll remember it really well. Alonzo, oh, it's a variable for 2. I do not need to know the address in memory that Alonzo is stored. So let me just show you this. So we get Alonzo. Then we can output the address, and this is the first operator related to pointers that we need to know about. It's the ampersand, also known as the reference operator. So if you put it in front of a variable, it returns the address, the actual memory address of that variable. There. I cannot type when I'm doing these tutorials. Seriously, I can touch type perfectly fine, but when I'm doing this, it's like I've got to look there, do this, talk, and type. It's like, okay, I'll be silent for a second. See, I think I spelled quiet wrong. I always get quite and quiet wrong. It's the bane of my existence. But anyway, we build the solution. We run it. Alonzo has the value of 2, and that is stored at this address. Fantastic. Now, variables are useful. We like names, like Alonzo is easy. 0018 FACO is not easy. It's like Morse code. Now, I memorized Morse code, and I probably only know about half of it now, because I learnt it in 5 minutes. How did I do it? Mnemonics. I'm actually quite big on mnemonics. I love memory palaces and all that nerdy, geeky wizardry stuff. But, for example, about. About? Why would I say about? Because if I emphasize the B, that means it's a dash, not a dot. So I know that the letter A in Morse code is dot dash. B is boisterously. 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 So it's a dash followed by 3 dots. C is careless children. So you have to remember these abstract things, and if you say them really weird like that in your head, you remember them well, but it helps you remember. So for me, these words with syllables emphasized are like my variable names for Morse code, because I can remember the names, can't remember the dot dash dash dot 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 help, SOS, whatever. Too confusing. So that's one reason we use variables. We don't program in machine code anymore. You can try it if you think you're hard. It's a stupid thing to do. Don't do it. Assembly is actually kind of fun if you've not done it before. I would actually recommend you look into assembly, like not x86 for the love of God. Something simpler. I used 68K, I think, and just write a small program in it. It's really fun. But then you'll realise why you would never, ever want to use it when you've got higher level languages available. It just doesn't make sense. Anyway, getting slightly sidetracked. So we can see the address using the reference operator. We can also declare a reference. Now, what a reference is essentially a variable that stores the address of another variable. Now, pointers, references, addresses, this like terminology gets very, I don't know, debatable at a certain point, so some people might argue with what I say. They might be right, I might be right, I don't know, someone's going to be right. Now, the key thing with this is a normal variable, you don't have to define it, you don't have to initialize it, let's get the terminology right. So I could have int Alonso equals nothing, or just int Alonso semicolon. But if you do that with a reference, you get an error. Requires an initializer. References must be initialized. They cannot not have a value. So let's say it equals A. Oh, A doesn't exist anymore. We changed it to Alonso. So now, if we just create another space here, and we do C, build solution, we should get, hey, we get 2. So what's happened there? Basically, we said, okay, the address of Alonso, we're going to store that in C. So when you console log C, you get the same result as you did originally for Alonso. But I don't want that. I want the address of C. Now you should notice these two values are the same. So the address stored in C is the same as the address that Alonso is stored in memory. So they're both referencing the same thing. These two names, C and Alonso, both mean the same thing. Good. Why do you need this? Let's go with the easy example first. Void increment dis stuff. I like easy to remember variable names. Yep. God damn it, JavaScript. Grr. JavaScript is going to mentally unbalance me. In 2 years, you're just going to hear, like, on the radio, not that anyone listens to the radio anymore, that some, like, crazy programmer went mad and started shooting people with a bow and arrow that he got yesterday, and it's right behind him, and he's really excited about it. Can't stop thinking about it. Yeah, detours. We like detours. I need to put this away. I love this. I've done archery for, like, 5 years, and this is just... Look at it. Oh... It is a horse bow, 54-pound draw weight, recurve-ish, and, I mean, look at it. It's all red, wrapped in leather. Ooh. I almost licked it there, and I thought that would be really going too far. Oh, we're getting distracted. Anyway, increment this stuff. It's going to take a value. Now remember, this A is not the same as Alonso or anything else, it's just the name of the variable inside the function. So, we are going to do A plus equals 1. So we're adding 1 to the value of A. So, let us all be amazed. Oh, not if I remove a parentheses, I should not. That's not a parentheses, it's a curly brace. I was like, you're an idiot, that's not right. You had a lecture on terminology and now you're saying this. Okay, so we pass Alonso into this function. Now, if you're a beginner to C++, you might not know what this does. If you've used it for a few weeks, you probably know what this does. So, Alonso, what will the value be? Will it be 3? Will it be 2? Will it be 10? I got it in there, in binary. Okay, the value is 2, it is not 3. The reason for this is because when you pass a parameter in like this, in C++, you are passing by value. So you are making a copy, and then when we do +1, we are adding 1 to the copy. We are not changing the original, so Alonso remains 2. What if you wanted to change the original? Very simple. You put the reference operator in front of A. So now instead of taking a variable, which usually gets copied, we are taking the address of a variable. So if we have the address, that's essentially just another word name for the variable. So A is now just another name for Alonso inside this function anyway. So if we add 1 to A, we're actually adding 1 to Alonso. So now, if we run this, we get 3. Now I'm going to have to speed up a bit because I'm taking my time and my internet is shit and it's quite late. So it's going to take me like 2 hours to upload this and the computer will keep me awake. It's so hot in here, like the fans go crazy even when nothing's happening. So anyway, that is a reference. I said before you can declare references. Yes, I said that. Good. I'm a good person sometimes. Okay, pointers. These are more fun. Int pointy. Pointy is going to equal the address of Alonso. Okay. Ugh. Is it? Apparently not. Oh, I didn't put the star. Sorry. This is the dereference operator. This is how you declare a pointer. So, a reference is an address in memory. A pointer is a variable that holds the address of another variable, or just a random location in memory. So, pointy is now pointing to Alonso. So, let's just comment out increment this stuff. I don't want it confusing things. So if I say pointy equals 5, and I did this on purpose, by the way, don't worry, I know it's an error, cannot be assigned to a value. We're actually trying to say pointy, the address you're pointing to is 5. Doesn't make sense. So we have to dereference it before we assign to it. So we put the star before the pointer. That means we're dealing with the actual value that we're pointing to. So we're dealing with 2, setting it equal to 5, so Alonso should be 5. And there we go, 5. Why is this useful? Good question. Well, for one thing, you can do this. And this will come in handy. You can set pointers to null. You cannot do this with references. So let's say you want to modify a pointer, or the value it's pointing to. I just did it there. That changes the value it's pointing to. Okay. So let's make another function. Change my pointer. Ugh. JavaScript, seriously, get the hell out of my head, man. You are not welcome. Okay. Now remember before I did an example and I said we are modifying the copy, not the original? That'll be important in a second. So let's say we have pointy, points to Alonso. We call, I'll get rid of this, we don't need it anymore. We call change my pointer. We pass pointy into it. Now, let's create a global variable. Int lol equals 42 has to be, come on. So what if we do this? Ah! I pressed something. What do we think will happen? By passing pointy into it, pointy holds the address of Alonso, which is 2. But what are we changing in here? We pass pointy into this. Will pointy be changed? I'm gonna die. Like, 50 minutes recording stuff is too long. At 9 o'clock in a 30-degree room. It's gonna kill me. Yeah, build solution. Let's run it. We get the value 2. 2 looks familiar. That's what Alonso is set to. By the way, I realise this is quite dry. You won't ever have to do this. You should not do this. And someone in the comments is going to say, oh, but you should be using unique pointer and shared pointer. Yes, if you're using the C++11 standard, which ironically this IDE is perfect for, yes, that is how you do it. But we're just explaining the basic concept. We don't need to go into shared pointers, unique Partly because I still haven't learned them myself. I don't do C++ these days. I imagine they're simple. Rant over. We got the value 2. Why did we not get the value 42? Just like we were passing a copy before, this pointer is actually a copy. So we take pointy, we pass it into here, but we create a copy of it, and then we're saying the copy points to lol. So if I just copy the cout statement and put it inside the function, do this, inside here, a will point to lol. So we'll yes, I should point out, if you don't use the dereference operator, it will just output the address you're pointing to. And oh my god, did that say boob? Oh yes, the old calculator days. I'm so mature. Okay, so we dereference a. So now we're getting the value at a, and since a is pointing to lol, it should be 42. 42 and 2, excellent. Cool. Now what if we really do want to change Alonso? Well, we're not actually changing Alonso, but we want to change what pointy is pointing to. We do the following. First of all, we actually output the correct thing here, so we want to know the value of pointy. I'll just quickly run the program. The value of pointy is going to be 2. It's pointing to Alonso. Why wouldn't it be 2? Now, we get to do something really fun here, and this will screw with your mind tonight. Oh. Dereference operator and a reference operator? What the fuck? Okay. I swore. I'm not allowed to swear during these videos. There could be some 13-year-old guy out there who's like, I'm learning pointers, I'm the best. He swore. And I might hurt delicate soul, and if I do that, I would not forgive myself. So, please, no swearing. No praying neither. Atheist. Okay. 42. So we get the life, the universe, and everything. Excellent. What the hell does this even mean? I mean, that's just crazy. Okay, so what we're doing, we're passing a pointer, but we're passing the address of the pointer. So that means we're changing the original pointer. So when we get in here, we're setting the original pointer, which is pointy, to point to the address of lol, which is a global variable. So by the time we get down to here, pointy is pointing to lol. And we can prove that because I can say lol equals 32. I can do this again. And that will output 42 and then 32. There we go, 42, 32. Simples! Now, I'm going to very quickly do something that I didn't do in my last attempt at recording this because I knew it was a bad idea. It is still a bad idea. I'm going to get it wrong. I've not looked up the syntax in ages, so let me see if I can do it. Okay. This is a stupid thing to do for the record. Okay, no, we want the void. Star. Let's just call it evil. And then we want, oh my god, we're passing in a, no, it is just, was it that? Yes! Okay. Never do this. If you can avoid it. Because this is going down painful. If you can take this to dangerous levels. And once templates get involved, it's, oh my god. Okay, so I've not done this in a long time, so this might not actually work. I hope it does. What this is a function pointer. Now, these are actually quite useful, especially in more dynamic languages. They're actually really beautiful, because you can do cool stuff. So what this is it's a pointer that takes a function that returns nothing, it returns void, and it has a single parameter that takes this. So in other words, I can set that function to point to this. You want to know how you get the address of a function? You don't actually use the dereference operator. I'm not sure what happens if you do that. Sorry, reference operator. You do this. I'm praying that this works. So now this is pointing to that function. So now instead of doing change my pointer, we should be able to do evil and still get 4232. This is a bit more advanced, so if you don't understand this, don't worry about it. It's a bit crazy. I'm just trolling you. 4232. Excellent. Now, Do you want me to really screw with your heads? I know you do. Okay. Give me a minute to think about this. This is, okay. I'm not sure you can do this. No, we can. Oh my god, we can. But this is completely pointless, but because we need to pass the pointer into here anyway. So, okay. Okay, in start ampersand. This is so dumb. Let's just call it point so we don't get it confused with pointy. See, this is how you know you're screwed in life as a programmer. Okay, now we can call this with this. I know I'm saying this a lot, my brain's starting to hurt. And possibly that? Can we do that? Oh my god, I think we can. So what does this do? I'll try and explain this in a minute once I figure out what this actually does. 4232, yeah! Okay. Oh, wait a minute. What is this? Why are we... No, we're not. We don't want to call that. That's cheating. Calling it twice. 4232. Okay. What did I just do? It doesn't matter if you don't understand this. I barely understand it. Okay. I declared a function pointer. And I set it to point to change my pointer, which is this function. So basically, evil is now change my pointer. I then modified increment this stuff to take the address of a pointer and to take a function pointer. Yes, you can pass function pointers into functions, and if you get even crazier, you can pass addresses of function pointers that point to other... Yeah, as I said, you just end up with a chain of insanity. See how far you can go with it. It's a fun challenge. So yeah, just look at that. Look at how beautiful it is. If you do that in production code, you will be fired unless there's a very, very good reason for it. So anyway, hopefully that's been slightly informative. It's a bit late and it's a bit rushed. I promised you a tune. Hold on. I don't have my recorder with me, so I'm going to have to use something else. And I'm going to get it wrong. Very briefly. Clear your mind of the insanity. You want to know a secret? My name is Stephen Surtees. On the internet I go by Foxcode. I have over 3,000 hours in all of Counter-Strike since CS 1.0. That is right. My god, that is a long time ago. The vehicles, that map, you had the APC. Brilliant. Age of Empires, hundreds of hours, actually probably thousands. RuneScape, now let's just say middle school, that's for that. Civilization, I don't know, I first played Civ when I was 4. My dad bought it for him, he didn't like it. I preferred it to the kids game he got me, Civilization 1. I didn't understand it, I just knew that a Legionnaire beat a Phalanx if the Phalanx was attacking, but the Legionnaire lost if the... It was brilliant. Anyway, I'm going somewhere. Master level StarCraft player at the time with Protoss, the troll race. I need to edit some glasses to come down to deal with it. All that. I've never played a single Zelda game. Hopefully you enjoyed it. See you later, guys.